Great, so we're going to look at now 2 from section 1 and 2, and this is giving us the equation that y prime is equal to 1 over t y plus t when t is positive, and we want to verify that y being equal to 3t plus t squared is a solution. So all we need to do for this problem is first to take a derivative of y with respect to t. So we know from the solution we're asked to verify that we can use this to find y prime. So in this case, that would be 3 plus 2t. And if we plug in this y into 1 over t y plus t, this gives us 1 over t plugging in 3t plus t squared for y plus t. This would simplify to 3 plus t, or 3 plus 2t. So because this matches with this, it's verified. Great, let's look at problem number 5 as well. So problem number 5, it's a very similar thing where we want to verify, except now it's an initial value problem. So this gives you y prime plus 3y is equal to e to the negative t. And we want to verify that the initial condition y of 0 or y naught is negative a half, and y could be, in this case, e to the negative t, the whole thing divided by 2, minus e to the negative 3t. Okay, great. So with this problem, again, what we'd like to do is to, well, I guess we could do two things. One, we might verify that when we plug a 0 into this solution, that's given right here, we do in fact get negative a half. So let's do that. So y of 0 is equal to e to the negative 0 over 2 minus e to the negative 3 0. So in this case, that's 1/2 minus 1, or negative a half. Great. So this does satisfy the initial condition. Now we want to make sure it satisfies the equation. So we need to, first and foremost, take a derivative with respect to t. So y prime would be, so you looking at the first term of this equation, we have the derivative of e to the negative t is just e to the negative t with a negative in front, divided by 2, minus, so e to the negative 3t, but we have a negative 3 that comes down, right, using the chain rule, so that turns into plus 3. Now let's plug this into the left-hand side up above. So in this case, when you have y prime plus, excuse me for a second, my screen's in the way, y prime plus 3y, this turns into, sticking in this right here, negative e to the negative t over 2 plus 3 e to the negative 3t plus 3 times y. So that would be plus 3 e to the negative t over 2 minus 3 e to the negative 3t. So this is 3 times y right there. Let's scroll down a little bit here. And we want to verify, before I do that, this is equal to e to the power of negative t. Well, that's not too difficult to do, just because we here have negative 3 e to the minus 3t and positive 3 e to the minus 3t, so those will cancel each other out. And then this other part can be written as, let's just write it as e to the minus t negative a half plus 3/2, which is just 1, so e to the minus t. Great, there you have it. So that's problem number 5 that verifies that this here is a solution to both this initial value and the original equation, so the whole initial value problem. Great. let's go ahead and look at problem number 10 here. So problem number 10 asks us, using the equation y prime equals to negative t over y, and we're asked to say, to use the corresponding direction field that's given right, in the diagram to draw some solutions. And then try to give the general solutions as formulas, and then we can substitute our answers in to see if it worked or not. So this might be kind of hard for me since I do not have this image on my computer, but looking at the direction field, it looks something like this. So if I had to guess for these sorts of problems, I would guess that these solutions are circles. So my guess here is that the solution are going to be circles. And the circle is centered at the origin. Let me get a different color here. All right, great. So I'm recognizing that this is, in fact, the ty graph. What would be a circle? So a circle's equation would be, you might think, well, y squared plus t squared, right, is equal to some sort of constant. So in this case, if we're looking for to have y by itself, we can do y squared equals c minus t squared, or you could, if you want to get y absolutely by itself, y could be c minus t squared. That would be sort of the top semicircles, or if you wanted to include the bottom semicircle as well, you might also include, let's do it in maybe blue, the negative down here. Great, let's go ahead and look at, skipping a few ahead, let's look at problem 25. So for problem 25, it asks us a couple of things, mostly about asymptotes. All right, so for number 25, our equation given is that y prime is equal to y squared. So one thing that we're asked to do is base our assumptions or our arguments off of a direction field. So let's draw a direction field here. Now I'm going to draw my axes like so. And so with the direction field, notice that my equation doesn't have any t values in there. There's no t's. There's only y's, which tells me that's sort of the directions don't depend, right, in my direction field don't depend upon the t value, right? So, for instance, if I have at y equals 1, say, I would expect to have a slope of 1 here, right? And we're always going from left to right. And so, since there's no t values, I would expect the slope of 1 to be the same for all the t values. Another way of saying this is that the isoclines, right, so the lines with the same slope in the direction field, are horizontal lines. And again, remember, isoclines are not solutions, but they are helpful for understanding direction fields. Then as the y values increase, right, so if y is equal to 2, for instance, then y squared would be 4. So when y is equal to 2, my slope is even more steep. So we get steeper going up. When y is 0, the slope is 0, right? So we end up with sort of zeros across there. And when we get smaller values, so if y is something like -1, right? Again, it has the same slope as +1, so it will look just like what was up there. And if y is something like -2, you have even steeper lines here, right? So this is a few of them. You could even go, more. So if you want to say like, hey, if we go even steeper, oops, that was kind of a rough sketch. They shouldn't be going to the left there. Ignore that one. But they keep getting steeper. So a couple of the things that we're asked here to do, tell if we expect vertical asymptotes or oblique asymptotes. Okay, so in this case, since it keeps going steeper and steeper, my intuition would tell me that yes, we are going to get vertical asymptotes. So solutions probably look something like this. And as you notice, because it doesn't require any t values or rely on them, all these are likely going to be translations of each other. And then down below seems something like this. And so, some of these solutions might, in the long term go to 0, but they seem to have these vertical asymptotes sort of as you think about going negative time or whatnot, or run time backwards. You might think about